Alright, today class what we're going to look at is the equation of ellipses. Now, ellipses are very similar to circles, except for, of course, they look more like a football versus being a circle. Now, for parts of an ellipse, of course, we still have our center here, and in this case, today we're going to be looking more at our center at the origin. So we got our center. It has two vertices that we call vertex on each side. Vertex, if this is a horizontal ellipse, it could also be a vertical ellipse. So if it's a horizontal ellipse, then your vertex is at a 0. And over here, your vertex is at negative a 0. Now your distance, we also have our co-vertex. Co-vertex being not, of course, on the regular vertex. This is what we call our major axis. This is what we call our minor axis. So on our minor axis is our co-vertex, which would be 0b or 0 negative b. Now the reference for A, B, and C as far as this goes, B, you notice, is your distance from your co-vertex to the center. A is the distance from your vertex to the center, and C is the distance from a focus, because we have two of those which we call foci, the distance from the center to the foci, or the focus. So in this case, C0 or negative C0. Now, with the major axis, if it's horizontal, whether it's horizontal or vertical, the length of the major axis is 2a. And the length of the minor axis, which would be the smaller, major being larger, minor being smaller, would be 2b. Now, with a horizontal ellipse, it has a standard equation that says x minus h squared over a squared plus y minus k squared over b squared equals 1. Our center is h and k. Our vertices are h plus or minus a, k. Our co-vertices are h, comma, k plus or minus b. And the foci is h plus or minus c, k. And of course, to be able to find c, or c squared, we use c squared equals a squared minus b squared. Now don't get this confused with the Pythagorean theorem, because that does throw off a lot of students. Now if this is for our horizontal, which means it's going this way, for our vertical, which is going up and down, changes a little bit. The a squared and the b squared switch. A squared is always going to be on the axis that it's going to, your major axis. So here some of our formulas switch a little bit too. So notice that center is still h and k. The vertices is h and k plus or minus a. The co-vertices is h plus or minus b and k. And the foci is h and k plus or minus c. Still c squared minus a squared, or equals a squared minus b squared. That one doesn't change. Alright, now, finding the standard equation of the ellipse having a foci at 1, 0, and 4, 1, and a major axis of 2, 6, with a picture that's going to look like this, because you've got to know whether it's going to be horizontal or vertical. Alright, so, to be able to figure out where we're going to start here, or where our center is, we're going to use the midpoint formula. If you guys remember, the midpoint formula is x1 plus x2 over 2, and y1 plus y2 over 2. So that's what we did. I did 0 plus 4 over 2, 1 plus 1 over 2, which gives us 2, 1, which would be our center. Now it told us that our major axis is 6. So since our major axis is 6, 2a is 6, so a is 3. And going back up here, since our center is at 2, 1, and we know it's going this direction, c has to be 2, which is the distance from the center to one of the foci. Alright, now since 2a is 6 and a is equal to 3, that means, of course, that a squared is 9. So we've got a squared. We still need b squared to be able to use our formula, if you remember correctly. So to find b squared, we use c squared equals a squared minus b squared, which would give us 2 squared equals 3 squared minus b squared, or b squared equals 9 minus 4, or b squared is equal to 5. You don't have to find b here, because all we're looking at is to find the general equation, and for that we need b squared. So just plugging everything back into our formula, we get, with our h and k, hk here, x minus h squared over 9, 9 being a squared, y minus 1 squared over 5, 5 being b squared, equals 1. And that would be the equation of that ellipse. Now, of course, what we're going to do is continue this tomorrow. with some more information than I can get into this video.